The water chiller, remember we were talking about the large chillers? Okay. On this particular one, you've got two sides, three sides really. Your center chamber, which is right in the middle, what they consider the barrel, right? Your evaporator barrel, this is all saturated with Freon. And what the Freon does is it cools your chill water piping. So this has tubes that go throughout. So this is my lines going out into my air handlers, right, in my building. So say I got leaving temperatures of 55 degrees and I got returning, say, of 64. So what happens is my refrigerant saturates these lines, right, and it cools down that water, right? Okay, then what I've got to do is I got to extract heat. It's a heat exchanger. I'm exchanging and extracting heat. Okay, so my refrigerant lines now go back through my compressor, right? So now I'm extracting the saturated heat from within my refrigerant lines to a compressor unit. But now I've got this other section here, which is called my condensate. So now I've got condensate water that's going to go up to my cooling towers, which is this next one. Okay, so this particular line here, okay, now goes into my cooling towers. Okay, and again, this particular process here goes up to the top troughs and large evaporative cooler, like I mentioned before. They do it with ambient air temperature, right? So I've got a fan, it's going to draw through my media. Okay, up to the top of the fan, some cooling water as it saturates and it bleeds down to my sump, and it starts to process all over again. Okay. Now, cooling towers. You name it, the size, every size of cooling tower you can imagine. Different types of construction, wood, metal, concrete, okay, composite materials, all those considered cooling towers. And now this one here is a natural draft ventilation. So again, pressurized here, okay, a lot lower than what it is down here, right? So you're going to have the natural draft coming up to this cooling tower, typically a power plant. So moving parts, I have my water that cascades to the very top, so I get the natural cooling effect. Okay, but again, is that going to require maintenance? What do you think? Look at this structure, all concrete. Think I need to inspect it once in a while? Sure I do, right? Okay. Here's another one. This is a bell tower. Notice what's here, right? So how am I doing my heat exchange here? I'm using my river water, ain't I? Okay, so I'm filtering that into my cooling towers, right? So that's going to require maintenance in regards to pumping systems and pipings and valves and controls and so on. And this one here, I believe it's on the Hudson. Okay, and it's a large manufacturing facility, okay? And in some cases, that I'm not sure on, okay? In some cases, you also get power plants. In fact, you've got a power plant right up here in University. And what is it, McClintock, the APS generation facility? Okay, yeah. So those are, again, the same concept. You have the cooling towers, which is what extract heat, okay? And here's another breakdown section of your cooling tower section. So here's your chiller. This is your evaporator or your condenser unit, okay? So what I'm doing is I'm running water, if you will, ambient water through my condenser or through my tubes. What I'm doing is I'm extracting the heat from my refrigerants, reintroducing it back into the chiller on the cold water side, right? But if you look, my pumping systems go back up to the top of my cooling tower. Again, media, draft, sump, pumping systems, and if you notice here is my water treatment system. So this is a process all within itself, separate process that sits alone. So again, any one of these are going to require maintenance in regards to the piping and, of course, systems. Okay? So if the pH levels get out of whack or get out of spec, it's going to send you an alarm letting you know that, one, you've got a potential risk developing. And again, low sump, so you got makeup water in your sump. So sensors and controls get back to the automation systems. Okay? And I showed you this photograph last week, and again, all condensers. And you'll notice the paint colors when you go through the central plants. You notice everything to do with condenser water is going to be a light green. So immediately you can tell by that pipe, that pump, that valve, that that's a condenser water. It's exterior atmospheric water. And everything considered on the cooling side is going to be a blue, a dark blue. So it's and then you'll see a lot of it labeled and tagged, okay? So once you walk into the central plant, you're going to be able to tell which is the differences between the two, okay? And of course, I think I showed this too. This is a two-pipe system. So when one season, you're going to use it for heating, and then the next season, you're going to use it for cooling, okay, depending on the time of year. Then, of course, a 4-pipe system is I'm using both. I've got cooling and heating water going through the circuits at the same time, so I can temper my temperature settings on my water systems. Okay, and again, typical maintenance: dampers, controls exhaust air. Okay, and then again, I think I showed you this one as well: variable air volume. This particular one here, they pump a constant level, but what you do is you use a damper to make the adjustments on your temperature. I'm not adjusting the temperature, I'm just adjusting the flow, the volume of air coming into the room. The cooler I want more air dumped down, noisier obviously, but again, it's a real simple design. It's not very expensive to install. So one of the value engineering opportunities is instead of having controls and independent systems, we'll install a variable or a variable a VAV, okay, system, okay, in my particular building or this particular floor versus doing individual controls. So that could be a value. It still serves the same purpose. And then again, some of the different types of features: automatic temperature thermostats. What they do is what they sense the central nervous system. I'm too hot, I adjust it. Your body tells you. So this is another controller. Your body has its own controller. Okay, transmits that information, control devices that adjust the HVAC equipment. Now, in the old days, remember the pneumatic systems I was talking about today? Back in the 60s, the 70s, that was the use. So we'll talk about that. So the thermostats basically is that. They set to regulate the temperature. The thermostats in this particular room, they might have this under control. Maybe there's a thermostat on the return air damper, which is back there. Okay, so in those particular ones, you have regular calibrations to make sure that they're within spec. Okay. You ever hear the old myths having a fake thermostat? Did you ever hear that? Oh, that's just a fake one. It doesn't work, right? What do you think? Is it myth or real? What do you think?
It's real. Can be real.
They're all real, okay? It's just, but I can't adjust it. It's like, no, because it's automatic, right? Okay. True story. Had BCAS alarm. Temperature was 2,000 degrees Fahrenheit. Alarm systems went off, right? I got a fire. I got a fire in my building. 2,000 degrees at a thermostat, it's melted, right? So we walk into this lab and there's an engineer standing on a chair with a little propane burner, and he's burning the thermostat because he wants the room to cool down. He's too hot. It's like, what are you doing? And he's caught red-handed, right? I mean, the thing's melted. In fact, you know, I've got a junk box. I'm going to bring in pieces and parts. When I do the electrical, I'm going to bring you some electrical devices, big breakers that are just a melted blob. And you're going to wonder, that could have caught fire. Yes, it could have. But again, part of the maintenance, I'll bring that thermostat in. Caught in red hand. It's like, what are you doing? Well, I was trying to adjust this because facilities never fixes these. They're automatic. All you got to do is call our number and we'll adjust your temperature. So needless to say, we took his burner away. Okay. So again, just pneumatic controls. All based on low pressure air, 15 psi. What I'm doing is I'm having my thermostat regulate my actuator. The actuator actually has a little spring on there. The less air, spring pulls back, closes the damper. More air opens it up, opens up the damper. Very simple design. Yes, all the ones in you. Yep. This looks just like coax cable up in the attics. That's why the electricians always cut those, and they play around with the air, right? Okay. This is the next generation. It was both electronic and electric controls. So again, now you use a room sensor, but instead of using compressed air, you actually use a transducer, the amount of voltage that you use and open up that damper, okay, actuator. Okay. Then you went to direct digital controls. Now you can put in a meter or analog where you can tie it into an energy management system. So this actually regulates itself, okay, depending on what your programs are. Typical problems, HVAC systems, you name it. Okay, cleaning, routine maintenance, watches, filters, lubrication. And then here's some different types of variations. Okay, here's what else I got. Okay, and again, part of your energy management programs, time of day, optimize start times. Okay, warm up and cool downs. Okay, cool downs may be early in the mornings. Warm ups may be late in the afternoons, depending on your set. Outside air, again, free cooling. And then your water side economizer, which is otherwise known as a plain frame. I'm using my cooling tower water to actually cool my building. So that bypasses all my chillers and goes directly into my process chill water, so I have a heat exchange.